The distributed AI enterprise, coordinating multiple AI systems across business units. Abstract. Organizations increasingly deploy artificial intelligence as distributed solutions across business units, functions, and geographies rather than centralized systems. This distributed approach promises localized responsiveness and innovation velocity but introduces coordination challenges including technical fragmentation, governance inconsistencies, duplicated efforts, and amplified enterprise risk. Drawing on organizational design theory and technology governance frameworks. This article examines the landscape of distributed AI deployment, analyzes its organizational consequences, and synthesizes coordination strategies grounded in established management principles. Key interventions include federated governance models, shared infrastructure platforms, cross-functional coordination mechanisms, and standardized risk frameworks. Organizations that successfully balance autonomy with coordination appear better positioned to realize AI value while managing enterprise risk. The enterprise AI conversation has shifted. Early corporate AI initiatives typically followed a centralized model, a data science team building models for deployment across the organization. Today's reality looks markedly different. Business units procure their own AI vendors, marketing teams deploy generative AI tools independently. Regional operations build localized prediction models. And functional departments experiment with autonomous agents, often with minimal enterprise visibility. This distributed approach isn't accidental. Competitive pressure demands faster time to value. Business contexts vary significantly across units. And accessible AI tools have lowered technical barriers. The result is what we might call the distributed AI enterprise, organizations running dozens or hundreds of AI systems, deployed and managed across organizational boundaries, with varying degrees of central coordination. Distributed AI can unlock innovation and accelerate learning. But without effective coordination, organizations risk technical debt, governance blind spots, redundant investments, and magnified compliance exposure. This article examines how organizations can capture distributed AI benefits while managing its coordination challenges. The distributed AI enterprise landscape. Defining distributed AI in organizational context. Distributed AI refers to the deployment and operation of multiple artificial intelligence systems across different organizational units, functions, or locations where decision rights, resources, and accountability are dispersed rather than centrally consolidated. This differs from distributed computing, technical architecture, or federated learning, a machine learning technique. We're concerned with organizational distribution, the structural arrangement of AI ownership, governance, and execution. Distribution manifests along several dimensions. Structural distribution places AI capabilities within business units rather than central teams. Vendor distribution involves multiple external AI providers serving different organizational parts. Data distribution maintains datasets across dispersed locations. Decision right distribution delegates AI procurement and deployment authority to local leaders. Research on organizational ambidexterity suggests that structural separation enables both exploitation of existing capabilities and exploration of new opportunities. Though coordination costs rise with separation, O'Reilly and Tushman. 2013. Distributed AI represents an extreme form of this challenge. Prevalence, drivers, and state of practice practitioner observations suggest distributed AI deployment has become increasingly common across sectors. Though comprehensive empirical data remains limited in published academic literature. Several forces drive this distribution: competitive velocity pressures. Business units seek faster deployment when competitors introduce AI capabilities at accelerating rates. Democratized AI tools, low-code platforms, API-based generative AI, and pre-trained models reduce barriers. Contextual specialization. Manufacturing optimization requires different approaches than marketing personalization. Local teams possess domain expertise, organizational path dependencies, M&A activity. Historical IT decentralization, or strong business unit autonomy cultures predisposed toward distributed models. Talent distribution. Concentrating AI talent centrally proves challenging when business units offer competitive opportunities. Distribution patterns vary by industry. Financial services often maintain stronger central governance due to regulatory requirements, while retail and technology companies exhibit higher business unit autonomy. Organizations in earlier AI maturity stages may distribute by default, lacking central capacity, while mature adopters may distribute strategically. Organizational and individual consequences of distributed AI. Organizational performance impacts. Distributed AI creates both beneficial and detrimental performance effects. Positively, organizations with distributed models report accelerated deployment timelines when business units control initiatives, eliminating centralized approval queues and enabling parallel experimentation. However, coordination failures impose costs. Technical fragmentation emerges when units select incompatible platforms, data formats, or integration standards. Financial redundancy accumulates through duplicate platform purchases and repeated foundational work. Governance gaps create enterprise risk when AI systems proliferate without central visibility, complicating regulatory compliance, bias management, and privacy protection. This proves problematic as governance researchers identify accountability sinks, situations where no single party has clear responsibility for system-level outcomes. Bovens. 2007. Knowledge fragmentation also prevents learning transfer, as insights from one unit's implementation rarely diffuse without deliberate coordination mechanisms. Stakeholder and workforce impacts. Distributed AI affects multiple stakeholder groups. Customers may experience inconsistency when different units deploy AI-driven interactions with varying quality or conflicting recommendations. Employees face fragmented skill development and career paths, though some value the autonomy distributed models offer. Compliance teams encounter growing burden assessing risk across proliferating systems without standardized documentation. Business unit leaders experience tension between autonomy and accountability, creating what organizational scholars call role ambiguity. Associated with stress and suboptimal decision-making. Khan et al. 1964. Evidence-based organizational responses. Federated governance architecture. Effective coordination often involves federated governance, establishing enterprise standards and oversight while delegating implementation authority. This balances autonomy with accountability through explicit decision right allocation. Research on federated IT governance demonstrates that clearly defining which decisions are centralized, architecture standards, security requirements, versus distributed, application selection, feature prioritization, reduces conflict and accelerates execution. Wheel and Ross. 2004. These principles translate directly to AI coordination. Effective federated AI governance typically includes enterprise AI principles and risk boundaries, centrally established non-negotiables, bias testing requirements, data privacy standards, prohibited use cases, mandatory design reviews at key gates. Business units proceed autonomously but must demonstrate compliance at defined milestones. Distributed implementation authority. Units select vendors and design solutions within established guardrails. Transparent exception processes. Clear protocols for requesting variances with defined escalation. Regular governance calibration. Periodic reviews adjusting centralization, distribution balance. This approach requires investment in governance infrastructure and ongoing calibration to maintain appropriate balance between control and autonomy. Shared AI infrastructure and platforms. Technical fragmentation diminishes when organizations provide shared foundational infrastructure that distributed units can leverage. This platform approach treats certain AI capabilities as enterprise utilities, standardized, centrally provided, locally consumed. Research on platform-based models shows that shared infrastructure reduces duplication while preserving innovation when platforms are modular and offer self-service access. Gora and Cusimano. 2014. High-impact shared infrastructure commonly includes enterprise data fabric, standardized data access layers and unified feature stores eliminating redundant engineering model development environments, ML platforms with standardized tooling, security-approved libraries, and built-in compliance controls pre-built model catalog, enterprise-validated models for common use cases that units can adapt deployment and monitoring infrastructure, standardized model serving and centralized performance tracking approved vendor marketplace, pre-negotiated contracts and security-vetted providers. The platform model requires ongoing investment to ensure shared capabilities remain competitive with external alternatives and responsive to business unit needs. AI centers of excellence and communities of practice. Distributed organizations benefit from human coordination mechanisms to transfer knowledge and maintain technical coherence. Effective AI centers of excellence, COEs, differ from traditional centralized teams by operating as enablers rather than owners of all development. Research on organizational learning communities demonstrates that cross-functional knowledge networks improve practice consistency when they focus on facilitation rather than control. Wenger. 1998. High-functioning AI COEs typically provide embedded consulting. Co-members temporarily join business unit projects. Transferring skills accelerator programs, structured support for high-potential initiatives, training and certification, enterprise-wide skill development tailored to different roles, internal knowledge sharing, forums, case studies and lessons learned, repositories, standards development, collaborative guideline creation drawing on practitioner experience, talent networks, programs enabling cross-unit connections and informal knowledge exchange. The co-approach requires careful positioning. 2. Controlling recreates centralization bottlenecks. 2. Passive fails to drive meaningful coordination. Standardized risk and compliance frameworks. As AI regulation intensifies, with the EU AI Act and emerging national legislation, distributed organizations face heightened compliance complexity. Effective risk management requires standardizing assessment frameworks while distributing execution responsibility. Practical risk standardization includes AI system inventory and classification, mandatory registration with risk-based classification, standard impact assessment templates, required documentation for privacy. Fairness security, customized by risk tier, automated compliance checking, embedding tests into deployment pipelines where feasible, third-party risk protocols, standardized vendor due diligence and contractual terms, incident response playbooks, predefined procedures clarifying roles across distributed and central teams. Standardization enables distributed teams to deploy AI with safeguards while providing enterprise leadership with risk visibility. Building long-term distributed AI capability, architectural modularity and interoperability standards. Sustainable distributed AI requires treating integration and interoperability as first-order design requirements. Modularity principles from software engineering apply directly. Defining stable interfaces between components allows teams to modify implementations without breaking dependencies. Baldwin and Clark. 2000. Forward-looking organizations establish enterprise AI architecture standards specifying data contracts, model interface specifications, monitoring requirements, API design patterns, and documentation standards. These should balance prescription with flexibility, ideally emerging through collaborative development rather than centralized mandate. Capability building and continuous governance. Long-term success requires developing AI literacy across distributed teams. Effective programs include tiered learning paths for executives, strategy, use case identification, responsible deployment, citizen data scientists, accessible ML tools, model interpretation, technical specialists, ML engineering, ML ops, and risk specialists, AI-specific governance. Additionally, governance should function as a continuous learning system. Leading organizations implement feedback loops capturing lessons from deployments. Governance retrospectives reviewing what's working. Incident learning processes, governance metrics tracking. And structured governance experiments. This learning orientation helps avoid governance becoming too rigid or too permissive as context shifts. Conclusion: the distributed AI enterprise represents both opportunity and challenge. Distribution enables organizations to harness diverse contexts and accelerate deployment. But without coordination creates fragmentation, governance blind spots, and amplified risk. Effective coordination requires moving beyond centralization versus decentralization debates towards sophisticated federated models combining enterprise standards with distributed execution authority. Several principles emerge: make the implicit explicit through system inventory and decision right clarification. Standardize selectively on risk guardrails and interoperability while preserving local choice. Platform strategically with shared infrastructure reducing distributed team burden. Coordinate through people via networks that drive knowledge transfer. And learn continuously, treating governance as dynamic and evidence-based. Organizations developing effective distributed AI coordination capabilities position themselves to capture AI's value at scale while managing risks responsibly. As AI capabilities grow more accessible, the coordination imperative intensifies. The distributed AI enterprise is here. The question is whether organizations will coordinate it effectively.